Okay, so in our last lesson we looked at Ohm's law, we looked at how the resistance is a constant if we're under constant physical conditions. We got that straight line graph through the origin for a conductor under constant physical conditions as we change the PD across it. So what happens if we don't keep it under constant physical conditions? And what our filament lamp is a piece of wire where we let it get really hot, gets to about 1200 degrees centigrade or thereabouts inside the lamp. So what happens there is that the resistance increases because the temperature increases. And if we plot the current against the potential difference, because this is our independent variable and this is our dependent variable, then what we get is a graph which is a curve. So from yesterday you'll remember we said that the gradient of the IV graph is 1 over the resistance. So R is increasing here because the gradient is decreasing. And you need to be able to explain why that is. Now actually I need to be able to draw this graph. I should have drawn this graph in 4 quadrants. Notice I'm always labelling my axes with my quantities and units. So the graph looks like that, and that's the graph that you need to be able to draw if you're asked to. So why does this happen? Well, we said last time that when you put your PD across your component, your lamp, your resistor, your wire, whatever it may be, that gives us a current through the component. Now the current is the rate of flow of charge, which means is the rate of flow of electrons, because it's electrons that are carrying the charge. In a metallic conductor, in solutions in chemistry, for example, it would be ions, but here it's electrons. So those electrons, if you imagine your conductor as being made up of a bunch of ions, and ions is the right word to use here, not atoms, and you have your free electrons. These ions are vibrating. They're vibrating in all directions, of course, but the ions are vibrating, so the electrons collide with the ions. So they pass on kinetic energy to the ions, of course, by that collision. They hit them and make them vibrate faster. Now they were vibrating before the electron collided with them. So you can't say they start to vibrate, they do vibrate faster. That's the thing. So the electrons, the free electrons, have more chance of colliding because these ions are now vibrating faster than they were. They're getting in the way more. So more collisions occur. So the resistance has increased. So the gradient of the graph decreases. Now I missed a point in all of that. Up here, I should have said, so the temperature rises. Because temperature is a measure of the average kinetic energy of the molecule. So if you increase the kinetic energy, you're increasing the temperature. So you have a filament lamp. When you put a PD across it and increase that PD, the current through it increases. But because it's getting hotter, then the resistance is changing, it's increasing. And the reason for that is here. As you put the PD across it, you get a current through it. The current is the rate of flow of charge or electrons. Those electrons are trying to get from here to here. They bump into my ions, note ions, not atoms. In doing so, they pass on kinetic energy to those ions, which means the ions vibrate faster, which means the temperature rises because the temperature is a measure of the average kinetic energy of those molecules. Because they're vibrating faster, the electrons have more chance of colliding with them, so more collisions occur, so the resistance is increased, so the gradient of the graph decreases because the gradient is 1 over the resistance. So there's the graph you need. There's the explanation you need for the filament lamp, and that's the symbol you need.